Okay, SQL Server indexing. So index, the concept here is we have table and we retrieve data from there, and then we also do DML operation, insert update delete operation. So to optimize the performance, we use indexing index. So first of all, we would like to understand the concept of index. So to understand the index, we can compare the concept of index with a book index. So suppose we are looking for a word. As you can see here, this is a book index, and let's say we are looking for the keyword ABC, or looking for somebody here. So we can see here this is a location where this word or whatever drug information is there. It's on the page 257 and then line number 61 or something. So we go there and we will be able to see it. But if we would not have this index, what we would do? So we would look for this word page by page for each page, and that would take more time. So exactly like this, SQL Server has the similar concept for index. So for small book, it's going to take less time. If the book is large, it's going to take more time. Key points of index. So first of all, the main purpose is optimization, faster recovery of select statement, and then DML operations. It will be faster as well. On the other hand, we can second point is on multiple columns we can create index on table as well as on views. Third point, if we create primary key, it will automatically create a clustered index. For that, every table can have only one clustered index, and we will see what is the concept of clustered index. And on the other hand, if you create unique key constraint, for instance department name, and that has to be unique, it will automatically create a non-clustered index. So these are the three key points here. And the type of index: clustered index, non-clustered index. We will look into it in details. So the main point here is this point. So data sorted based on index key. Like for instance, if you have student ID, so index key is if you said it student key is the index ID, then based on that it will be sorted. The data will be sorted that way, and even data will be stored based on that. And data will be stored on the bottom part. We will see how it stores. On the other hand, non-clustered key, it deals with the pointer. So it will basically point to actual data where it's located, and it will be sorted with the key that we will be creating, but data will not be stored there. Once we see the picture, we will be able to understand more. So first of all, we have clustered index, and our index key is the ID that we have, and index will be organized in this manner. So this is intermediary node, this is the root node, and then data will be sorted with that. For example, 1 to certain numbers will go on this point, another will go on the right point, and then on the bottom point it will have direction where the lower values are there, and then on the bottom leaf, this is called leaf node. So here ultimately the data will be stored. So if we see this picture, we will have a little better idea on clustered index concept, that this is the root level, okay, 1 to 200. You come to this point, and then intermediary level, you are going to the left. From 1 to 200, go to the left. If it's 100 to 200, it will go to the right, and then on the bottom 1 to 50, go to the left, okay, and then 50 to 100, go to the right, and then on the bottom level, this is actually the data itself is there, okay. So we just saw that. So if it comes here, and on the bottom part, it will have direction to the table, physical data is there. And we can imagine that way, that for 1, let's say student ID 1, you identify student ID 1, and here on the leaf node, the data will be stored for all the rows. It will be stored on data pages. So that is the main concept of clustered index. Another thing we can see here, clustered index is like root level, intermediate level, actual data. Actual data is on the leaf node. We can see here another representation of clustered index. It reaches to a leaf node, and on leaf node you have physical data like that. So there is another representation. The organization of data is also known as B plus tree or binary tree. So the concept here is tree has root and leaf. So but leaf is on the top and root is on the bottom, but here they invert that, and then root goes on the top, okay, and that is the root, and on the bottom it's leaf. So that is the concept here that has been implemented. So we can consider that like this. So root is on the bottom, all the data, and then root is on the top and leaf level is on the bottom. That is inverted tree. So that is the implementation compared to this data. Now non-clustered index, discussing about non-clustered index. So this is one scenario we can understand the concept of is, let's say name you have, so name non-clustered index. So the index key will be sorted on the tree, okay. So root level will be there, intermediate level will be there, and the direction same like the clustered one. But on the bottom, the leaf node will not represent will not have the data. It will have only a pointer, and pointer will point to, if you have already a clustered index on that, it will point to that actual data on the clustered index. But if it doesn't have clustered index, then it will be called heap. So you will have only the data pages, and that will not be sorted. So it will point to that one wherever it is, but it's going to take more time. So if you have clustered index already and you create non-clustered index, it will help retrieving the data faster, way faster. So if we see this picture, clustered index already there, and it's on author ID, which is this, and based on that data is located. Okay, this is the leaf node data representation. So cluster, and now non-cluster index, you create a non-cluster index on last name, and what it will do, it will create again a B plus tree where the index key will be last name, and based on that data will be sorted, okay, and then it will have on the leaf node information about specific person. So it will go, so if you are looking for this person, it will go to the left, and then it will have this information. And here we can see, like, we are looking for white, and then and this is the query white. So it comes here and identifies white, and it has information about like this ID, since you have already a clustered index. So, and then it will point to that clustered index, and it will, from there it will find the data and return it. So you can understand. So if you just search on name, it will not get it if you don't have non-clustered index. The search will take more time on that, but because your name is not sorted, so but and indexed. But if you have a clustered index on author ID, so information will be sorted there, and leaf node, all the data will, this is all the information that you have on the leaf node for clustered index. Now if you have non-clustered index, you are looking for what? You're looking from the table for only a person information whose name is white. So with the B plus tree, it will identify where is white, and it will go to the direction. This is, and it will have only the pointer, okay. So ultimately the concept here, it's a index page, and index page will have information about where white's information is there, and it will point, if you have clustered index, it will point to the cluster index, and this is index page for cluster index author ID, and here it will search it and will retrieve the information. So that's the way it works. Earlier I said that if you don't have a clustered index on a table, it's called heap. Okay, even if you have non-clustered index, if you don't have a clustered index, it will be heap. And if you have heap and you just create a non-clustered index, it will take more time to retrieve the information. Why? Because you can see there is a gap here, and that is called bookmark lookup. So it's a non-clustered index. It's coming there, and if once it's identified, there will be like a gap here to point to that table, because table data is not organized. The table pages are not organized, so it will take more time to identify where the exact page is. But if you would have a clustered index, it would search on clustered index, which we saw in this picture. So let's say if you would not have the last name as non-clustered index, what would happen? It would scan through your index if you to return this record. But since you have the index on that, it will seek directly pointing. Seek means like pointing to the specific place to retrieve the data, and scan is like checking each and every page like that, index page like that. This is a query execution plan that we saw in the class. So as you can see here, it's index seek. So it's seek means like it's directly pointing to specific index page to search the data. But if you see index scan, which implies it's scanning through index, even a cluster index scan, if you see that. So we will see in details about execution plan in next upcoming slides. As we saw bookmark lookup a few minutes back, so bookmark lookup in execution plan will look like this, which represents here the gap. This is bookmark lookup. So a couple of points for indexing. Non-clustered index, so queries that don't return large amount of data. So if your selection is limited, so return value is limited. Your table is large, but your return value is limited. Then you can use that. So limited data return from large table, use non-clustered index, and then exact match. So like operator, if you have like operator there, I think it will be delaying on your return. But if it's exactly matched, like you're looking for where on the where clause, like the ID is greater than this or between this, so this kind of thing, it will return quickly. So exact match. Like operator will also return. It's not like that, but it will search more based on your IDs or non-clustered index that you will be creating. Covered index, covered query means so if you want non-clustered index is used on covered query, like for example, you have on select you have few attributes, and then you have joins and not joins, actually you have where clause and then group by. These attributes you to cover that on your selection, to optimize your query, you create a non-clustered index. So that is what it means about covered query. There is also one more term is covering index. We'll read that as well. Column with a high degree of uniqueness. So obviously repetition should not be there when you put an index. If it has repeated attributes, repeated values, you don't want to put their index. It won't be that useful. So that is the point we need to remember. Another thing is we have clustered index on the other hand, and then we will use where query returns large data, because it will be faster. You have data sorted on index pages, so it will easily retrieve the data. So you can return large amount of data, and then you can return based on range as well. So large range, even you can return that in your query. And then uniqueness, both of them has to have uniqueness. And then foreign key, So whenever you, where will you use cluster index? If you are using joins, so joins, for example, you have primary key, foreign key relationship, and you join two tables to retrieve information. On those attributes, you can definitely use cluster index. So that will be useful to retrieve the data. And group by attribute or order by attribute frequently used. That is obviously can be used as non-clustered index, because sometimes you don't know what will be your query. But if your query is determined and same query you are running, and you know ahead of time that this is the query that we will be running and it's important query, you can do that way as well. But group by and order by can be used on non-clustered index. Now, a couple of notes there. Avoid over index. So already if you have index and on one attribute, you will try to avoid, not like it's not necessary, but try to avoid like more index on the same attribute, or repetitive attribute, or over indexing if you don't need it. If a table is like frequently updated, so DML operation, insert, update, delete, is frequent. So index has a cost that is important. So if you are doing insert, update, delete frequently, so all the time your B tree will be reorganized. So that will take more time, okay, to reorganize when you do DML operations, insert, update, delete operation. So if it's heavy, too much going on a table, you should try to avoid indexing on that. Or what you can do, you can drop the index before you do this kind of large activity, like, okay, for next 2 hours or 5 hours, we will do a lot of insert, update, delete, or bulk insert, or bulk update or something, bulk insert, bulk load. So this kind of thing, you want to drop the index, and once your operation is done, you can put the index back. So that's another way you can follow. Okay, I think this point is more important here. So avoid indexing on small tables. So if it's small table, there is no use of even you see the scanning is going on, it's fine. Like you have 5,000 rows or 10,000 rows, you don't need to create their index, or even 100,000, 1,000, or even less than 500,000 records. I think that should be also fine. So if it's a small table, less data, don't worry about index to be created there. And covering index. Covering index means like if you are writing a query, and that query has index scan or bookmark lookup, especially bookmark lookup you are seeing there. So index has to be optimized, okay. And then if you see still, even if you have a non-clustered index, but still you are seeing bookmark lookup like this, the way you can remove it, because if it's lookup, so lookup has cost, okay. It will take more time to retrieve the data. You have to remove if there are bookmark lookup. So on a select statement, you have select attributes, and then you have where clause, you have order by. So find all the attributes together and make a non-clustered index key, non-clustered index with all the attributes that you have on select, where clause, order by. Put one index, and it will create a view. Normally some people say it will create a view, or you can say it will create a non-clustered index, and it will improve your performance. You will not see bookmark lookup anymore. So that is about covering index. So index fragmentation. So if you are doing DML operations, insert, update, delete operation frequently, index structure will be fragmented, okay. And then for that you have to defrag the index, so it will reorganize your tree and index structure, so it will help you to retrieve information faster. For that you need maintenance window. You cannot do it when the production activity goes. So on weekend or off hours or non-peak hours, you can enable that based on business agreement with the business team, that we are going to do maintenance on a table or certain tables, and you will see slow performance. So you have to have the approval for that. So simple index, compound index, if your index has one attribute, one column, then it will be called as simple index. If you have more than 2 columns on the index or more columns, it will be called compound index. So one clustered index per table, and 999 right now on SQL Server 2014, you have non-clustered index. You can have that many, though you don't need it. It's just you need to remember that. It can be asked in the interview. Statistics. Now, to retrieve information from a table or do operations, index by itself is not enough. There is a term called statistics or stat update. So statistics is the thing that it will the data distribution mapping. So what it means is for a column, specific column, whatever data you have. So when you have you have a request for returning value for that specific attribute, let's say you have name, and if you have name, certain range of name or certain range of social security number or certain range of IDs, if you have statistics, it will understand that okay, I have to query, and this is internal processing information for query optimizer. So what it will do, it will check the stat, and stat will have the trend or have statistics there where exactly this row are located, and based on that it will help returning the data faster. So there are some key points here. So it will influence the query execution plan. So the query execution plan is like how when you run a query, a SQL Server internal processing unit, how it will retrieve the data. So that is and how optimistically it can retrieve the data. So for that, the statistics will help, and stat contains the data distribution mapping for a specific column. So so if it has to return something, and that is the last point that we have, the query optimizer use stat to estimate the number of row processed at each level of query plan. So for example, you have query plan and we have to retrieve this many data. So it will have the data location or data distribution mapping. So it will help query optimizer to retrieve that set of row for a specific unit. So that is statistics. So you have to have statistics. One table can have statistics for all the tables if you are doing activity on that. Let's say you have automatic statistics update enabled. So for each column, what it will do, whenever you do an activity, it will create a statistics for that specific column to have a trend where this data are located. And when you run a query on that specific column, so it will use that to retrieve the data faster. So you need to make sure you are doing constantly statistics update, and it has some cost, obviously. So you need to do it off hours, or even if you do business hours, you have to have approval. And there are some ways to do the maintenance. For that, we will look into it. Now we will see some script from SQL Server for index as well as statistics. So here is one example, statistics, index creation. So we have a table that we can create, and we are creating cluster index. As you know that if you create primary key, automatically it will create your cluster index. So it's just an example to show you, like, if you don't have primary key and you're creating index, this is the way you can create that, or separately you can create this, and later on you can create the primary key on the table. This is non-clustered index key example. Okay, so how to create non-clustered index? We can graphically using the graphical user interface, we can do that. As you can see here, we have a couple of tables. Let's show you. This is like the key on a reverse way, and because it's non-clustered index, and it's a key, it's a silver key. and then golden key is clustered index, and both of them are automatically created. We didn't create that. How to create a new one? So right click on that, new index, non-clustered index, and then you select the attribute. Okay, here you add it. Okay, and you select whatever you want to select, and then you can just click OK. If you want to see script, click on script. Okay, and then this is the way you can also learn. These are the extra statements for pad index and others. And for statistic for index, I would like to add one more point, that is fill factor. Okay, what is fill factor? Fill factor is I discussed in the class that on a book, like for example, if you have a page, if you go to a page, okay, and then that page can grow, okay, in terms of data. So you don't want like to have a split page when you are discussing a topic in a book. So if you are talking about some medication, so you want all the information to be on one page, what will you do? You will leave some extra empty page so that if more information comes, you can accommodate that on that specific page. So same like for data, you don't want data to be splitted. So on a specific page, you want to have empty space. This is called fill factor. And for standard configuration, you can have 20% free and 80% data, or maybe 30%. You can have it for fill factor. On a database property, you will be able to change that fill factor to whatever percentage you want. So right click on the database property and go to database settings. You can set it here, default index fill factor. So how will you check your indexes? So you go here on a database, expand that. Okay, under table, each table will have index column. So if you don't see any index here, so that implies your primary key probably is not there. So you at least see a primary key, clustered index, and then you have to add non-clustered indexes based on your query. You can use a statement to check fragmentation. Here with this script, we can see like, okay, these are the tables, okay, and it has fragmentation level. Okay, if it's more than 30%, and if it's a huge table, you must do defrag and bring it down to 30%. We will see how we can do the defragmentation. With this script, you can see like a table, what is the index that is there, okay, and column name and all information will be there. So you should be able to see index information with this query. So it's there in the PowerPoint index query that we discussed, 2 indexes. Now to do index maintenance, we use Wizard in SQL Server Agent, or using Wizard we can do that as well. So going to management, under management we will see maintenance plan. Right click on that and you can do any kind of maintenance. So you put the name of maintenance plan ABU 1028. Okay, now if you want to do index reorg or rebuild, okay, rebuild has more cost, reorganize has less cost. It's almost similar thing. And then if you want to do statistics update statistics, automatic update statistics, you can select that as well. And then you do that and you select whichever database you want to use. Okay, for your maintenance, and click next, and then click next, and you finish. And once you finish that, what will be happened? It will create a SQL job, and this is the plan. So if you execute that, your maintenance will be done. So you can schedule that whatever time it will run. So add new schedule, and then you can make it like a one time or recurrent. Okay, Monday or a daily basis, you can select even daily basis, certain every 1 hour or something, or maybe daily at 12 a.m. it will run like that. Click OK and it will run based on that. So that is maintenance of fragmentation, index reorg, reindex, statistics update. All this can be done. Statistics update, another option, you can do it that way for every database. You can even enable the autostat update. So if you go to database properties and go to option, database properties, go to option, you can see auto statistics update is true. So it will take care of whenever you do any DML operation, it will handle it automatically. So which is better, but it has some cost, you need agreement, but I would prefer to enable that. So there are no extra overhead for that. But it will do it when the activity is less. It will not do I mean continuously. So you may need to have additional index statistics maintenance on off hours.